Warning! This video includes mains AC, which can cause serious injury and death. And you can, well, hear actually how dangerous it is. Now let's build that puppy here. I'm shooting this after the fact. Welcome back to the second part of creating an isolation transformer from two dead UPS units. And mechanics and wiring. So interestingly, most of the stuff I need is already here. In the back there's an IEC connector and there's overload protection. So a fuse and all I need basically is a plug in the front. I don't really like the idea of using these plugs in the back, but that might change. And I want to add AC mains power meter for the output, just so I had that laying around. I think there was a review for that card link somewhere. Let's see how it goes. But my main problem is fixing the transformer, the second transformer in the case right now. And unfortunately, there's not really a good solution for that. I mean, I can place him this way, but then these feet are basically, free floating. And I have to go quite a bit to the front. That means I have less space here for whatever I want to put into the front. This should be still okay though. And this should fit. Or I can put it, let's say, this way around. Then these feet are again free floating and the whole thing is even in that state, it's not really stable, but I don't know why. This maybe because here the feet are a little bit bent, so I won't ignore that for a minute. I would, would I? I mean, gain more space? You be the judge, but trying to align that here. This against something like that. Oh yeah. A lot more space. Okay. Then I guess I will put it in this way. That is with the this way around. Okay, there's enough space here too, so no problems. And I will need the cage to be inserted here. That cage again, because this is basically holding the front plate. So the second transformer will live in that cage, and if thermal problems arise, I will solve them then, meaning lots of cutouts and ventilation. So I'll come back to you as soon as I have drilled some holes and the transformer is in. So 4 drops of cutting oil and, well, 1 drill later, but don't worry, it was a cheap Chinesium drill. And $4.99, that's Deutsche Mark, so about €2.50, £2.50, the whole set back then, when this was not sold on Alibaba or Banggood, but still here in the shops. Yeah. Anyway, little hiccup. Yeah, my holes were at the location of the feet. Okay, so yeah, I removed them for now, and yeah, maybe I need a cutout here, or yeah, we'll see. Just a small hiccup. Let's yeah, put the transformers in. Yeah, the transformer went in quite well, but now comes the next hiccup. Yeah, exactly here. Yeah, that part latch of the case, which should be screwed down here. Can I zoom in a little bit? Yeah. It's interfering, and I have to take a little bit off that corner, I guess. Yeah, well. Okay, just because this will probably make nice sparkles. Yeah, looks good. Let's give it a file it a little bit, and yeah, let's see if it fits. Yeah, fits just fine. Perfect. And I got the feedback on. Yeah, just some super glue, and it's fine. Had to cut here a little bit just to give some allowance for the screw here. But yeah, fits nicely. Now it's no longer scratching on the table. And I finished the first cutout, the biggest one, for the meter. And yeah, doesn't look too bad. Yeah, it's not quite fitting, but yeah, it's okay. And this time I even remember to look at the back side, so there's enough space for cables to get out. In between I went shopping, and yeah, talking about putting lipstick on the pig, and yeah, a nice switch here, yeah, with a little neon lamp inside, and yeah, a black socket to put in, and yeah, instead of a blue one, just yeah, wanting to keep the front plate nice. Oh, okay, next cutout, that one here. Okay, the next cutout, yeah, not quite round, but yeah, it's fitting nicely, also with the holes for the screws. Yeah, so yeah, one cutout left, if I could find it here, for the switch. Okay, last cutout finished, and yeah, looks good to me, at least. Yeah, quite nice. Time to clean up all the plastic stuff that's yeah accumulated around here, and then we can continue. And I did most of the work just using files and some saw blades here, and I used with a power drill that monstrosity and some other drill bits, and I explicitly avoided 1 second, using a high RPM power tool, because this is ABS, and ABS, if you try to work with a Dremel or a Proxon on it, it will melt and it will get very, very ugly. And it's really simple, easy to saw and to file. So yeah, and the result, yeah, it's okay. Well, not too shabby. Yeah, and now we're almost at the point where I need to wire up the whole thing. There's one little obstacle we have to overcome, and that is meeting these two parts up again. And yeah, it's almost working, but only almost. Yeah. Okay, so in effect I need some cutouts here. I'm very happy. Oh, is that? Oh yeah, that was also coming out again. Just a wee bit. So we basically need, if I can get this out again here, we basically need, yeah, let's make a cutout, yeah, for around here. So yeah, from the top down here, here, and here. So yeah, we have nice access even if that plate is in. Yeah, metalwork. I come back to you as soon as I've done the cut. Or maybe I film a little bit if there are some sparkly things flying around, but I don't think I will do all the cuts with my Dremel. And because it was so nice last time, yeah, the Proxon again. I want to point out that I didn't broke a single disc this time, okay? There we are. Well, some filing required. So, hopefully we are finished with the body work. Let's give it a quick try. Oh yeah, that looks so much better, and this will of course go here in the front. And yeah, it's time to wire everything up, but before we do that, yeah, maybe a little circuit diagram. So the idea is the following. Yeah, we come here on the existing IEC connector in the back, and we use this, yeah, resettable fuse. Yeah, you gotta fuse that stuff. And then we go into neutral and the low tap of the high side of the first transformer. Yeah, we already know that part. Simply connect both low sides of the transformers. No fuse here. We want to keep the resistances, resistive losses as small as possible. And then on the isolated side, we take neutral and the lowest tap of the high side of the transformer. We go into the meter. Okay. And then we go into that switch, yeah, both lines. And then we go into the output socket, only 2 poles. Yeah, the earth connections will not be wired. Yeah, and the reasoning behind that is, okay, as soon as I plug that into mains AC, my instrument will light up, and only if I throw the switch and connect the output, that will light up. So I know when I'm already, if I have voltage here, and if the whole unit is plugged in at all. Yeah, you could add another switch here on that circuit. You could add another fuse in that circuit here, but yeah, this is, how shall I put it, the highest energy coil, okay? Because, yeah, with each transformer core, we got some thermal losses. So the most power that we expect, electrical power, will be in that coil. And so if we fuse that coil, if we have an overload here, that fuse should, save the day. Hopefully. We'll see. Let's start at the back. So the IAC connector and the resettable fuse is already wired in the way I want it. And we just need to get that into our transformer. And because I might want to reuse these transformers at a later date for something else, I don't want to cut that connector off, so I'll get the original connector off the board now and get it somehow attached to these cables. So here it is. There are, I don't know, at least 3 layers of heat shrink around here just to make it safe, and yeah, fits nicely. And I closed up the back again with some plastic cover. Yeah, that was of course included. Could close that up too, but I don't bother right now. So the next thing would be the very high current, 30 amps or so under full loads, low voltage sides of the transformers. Let's see what I can find. So these were the original wires, 2 pairs of them coming off the controller board going to the low sides. And yeah, I used these really massive clamps, and hopefully the resistance is low enough. And these wires are, if I read it right, 12 AWG. Okay, let's start with the black one, because that's the shorter one. Okay, and we can take the shorter route to here. That's why I haven't screwed down the cage yet. Wonderful. Yep, fits. And then we have the white one. That can go here. Okay, and now we form the cables a little so don't get into the way. Good enough. And no, this is not really sharp, and this is really thick isolation. Maybe I put some tape around here, the edges, but for now, we are connected. Yeah, I could shorten these things if there are too many losses. Yeah, sorry, my headphones. Next stop, our isolated high voltage to our front panel. And I laid everything out here because the cable has to be long enough so it can reach when it's disassembled to the meter. So I'm just taking a regular AC mains cable here, and yeah, the connector here on this side will be the same, and yeah, then we'll snip it off at the right point, hopefully. So, all done. Yeah, cable going through the meter. Yeah. Oh, next stop, meter switch. So the connection from the switch, I hope I have the right side here, to the meter is done. Last step, from the socket to the switch. Okay, that connection is also done, so let's put everything together, hopefully. Got a little bit dirty on the bench. Okay. Come on. Huh? Okay. I'd love to say that's it, but there's something missing here. A satisfying cluck that I don't get. Okay, now I get it. Wonderful. Let's fire that thing up, huh? I'm switching, out of screen the power supply to that thing, and oh, that looks good. 234 volts. Yeah, I experimented some, but it's loud. Do you hear that hum? Wow. And now let's see. It comes on. So, I did everything right. But it's loud. It's really loud. Let me investigate a little bit. So, that noise, can you hear that? Just a second. That noise is not coming from the transformers, it's actually the cage that is working as a membrane. And yeah, 50 Hertz loudspeaker, big magnet in the back, and the membrane vibrating. Anyway, that shouldn't stop us now. We'll go back to the front and do a final isolation test. So that buggers off to mains earth, and yeah, I plugged it in. It switched off, and you see we already have some voltage. These are just stray 50 Hertz electric fields inducing some voltage in all these cables. And if I switch it on, we have again 55 volts to ground. But let's put a little load resistor in here again. And yeah, that humming, 50 Hertz humming, is probably 100 Hertz, because yeah, my membrane, the cage, doesn't care about the polarity of the magnetic field. So our 1K resistor, and yeah, voltage is gone. But let's try a 1 mech resistor, because 1 mech is incidentally the usual input resistance of an oscilloscope. Oh, come on. So we still have 55 at 1 mech. So this is just really induced stuff, maybe a little bit leakage, but yeah, you see, if I put my body across it, we are down to 4 volts. Yeah, that's to be expected. We can use the other plug. Yeah, body resistance goes down to a few volts, and with 1K, it's really nothing. So, isolation test worked. Load test. This will be more interesting. And yeah, before I do the load test, we can do actually, yeah, 234.8, 234. We are basically spot on. Yeah, plus minus 1 digit. It's a Chinese meter. What do you expect? So it seems perfectly okay. I can even switch it off. And yeah, let's see what our current main voltage is. Going. Yeah, 237, 238. So 3 volts drop without a load. And now let's put some real load on it. Just a second. So I have this wonderful hot plate here, and we can just plug it in and switch it on. Ooh. Lots of power. Okay, this will be getting hot, of course, dissipating some heat. And yeah, we'll see. This should, it's an NTC heat plate, so it will regulate down. Well, and the voltage broke down to 220 volts, and it's slowly rising up at that load. That's also to be expected. But we are still in the range that is, well, an acceptable AC mains voltage here in Germany. What I want to know is, are my transformers getting warm? Not a bit. Okay, so no thermal problems. Yeah, huh, what can I say? The noise, it's annoying. Maybe we have to do something about that. So, here's the plan. I will, get the cage out again and cut it down here. So there is no metal around the transformer cores. Okay, I'll be back in some while. So I cut off, the whole rest of the cage. Only these two, ears remain, holding that up in the front. Yeah, it's sturdy enough still. I had to add, of course, there was only the one screw down here. I added a second screw, so it's got a little bit more stiffness to it. Yeah. Let's see how it sounds now. And power. Okay, there's still some noise, but it's not as bad. Yeah, the ears are also vibrating, but they are further away from the transformers, so it's not as loud. Now, close that up. Oh, wait, I give you a new sound. I have to make sure, of course, that that I have the same level when I'm cutting the video, same sound level. I'll do that. Anyway, let's close it up and listen again. It's closed up, so let's power it up one last time. Yeah, and the angry transformer noise, it's still there. It's not as bad as it was, but yeah, you'll be the judge. I guess when I will use that thing in videos, you will have that really powerful hum in the background in the future. Until I can bring myself to buy a commercial isolation transformer, and even then it might hum too. So yeah. I told you I will show at some point how not to kill yourself working with AC mains using such an isolation transformer, and how not to blow up your oscilloscope when you're working with AC main circuitry using such an isolation transformer. But that will have to wait. I will put that into a real tutorial, a little bit more structured than this small project build. Till then, bye.